Have you ever just stopped and wondered why everything, well, works? Why the fundamental laws of our universe seem so perfectly dialed in for stars to form, for planets to exist, and for us to even be here talking about it? All right, let's get into it.
You know, this is one of the biggest mysteries in science, what they call the fine-tuning problem. It really seems like our entire universe is balanced on a razor's edge. If the basic rules were just a tiny, tiny bit different, nothing we know, not stars, not atoms, certainly not us, could even exist. So what's the deal? Are we just unbelievably lucky? Or is there something deeper going on?
So yeah, that gets us to this idea of our just right universe. For decades, scientists have been floored by how incredibly precise the settings of nature are. It's kind of like walking into a room and seeing a pencil balanced perfectly on its sharpest point. You'd never just assume it fell that way by chance, right? You'd think something was keeping it there. And just look at this. This shows you exactly how fragile that balance really is. Take gravity, for instance. A little stronger, and bam, the whole universe collapses back in on itself in a big crunch. A little weaker, and matter never clumps together enough to form stars or galaxies. And it's the same story for the other forces. Tweak the strong nuclear force just a bit, and you either get no atoms at all, or stars that burn out in a fraction of a second. The window for a universe like ours is just incredibly, incredibly narrow.
Okay, so this observation, it leads to a really powerful new way of thinking about it. What if this isn't about luck at all? What if the universe can only exist inside a very specific stability region? So instead of it being some wild coincidence, maybe these values are the only ones that let a stable, lasting universe even get off the ground.
And you know what? This whole idea, this stability region, it isn't just some weird abstract thing that only applies to the cosmos. As it turns out, this principle of balance is a pattern we see in pretty much every complex system you can imagine.
I mean, just think about a star like our sun, right? It's in this constant epic tug of war. On one side, you have gravity, which is relentlessly trying to crush it into a tiny ball. But on the other, the insane energy from nuclear fusion at its core is creating this massive outward pressure, trying to blow it all apart. A stable star can only exist in that perfect, delicate balance between total collapse and a runaway explosion.
We see the exact same principle in a system we all deal with, an economy. If there's too little money and activity flowing, it can collapse into a depression. But if there's too much, it can spin completely out of control into hyperinflation. A healthy, stable economy has to operate in that balanced sweet spot right in the middle.
All right, so here's the big takeaway from all this. From stars and economies to entire ecosystems, it seems that all stable, complex systems exist in what's called a dynamic equilibrium. They are always constantly balancing on that fine line between falling apart and flying apart. This isn't some rare exception. It appears to be the fundamental rule for anything to last. So if stability is the real key here, is there a way to actually model it? Well, one proposed framework for trying to understand this universal principle of balance is called Triune Harmonic Dynamics.
Okay, so what is Triune Harmonic Dynamics, or THD? Well, put simply, it's a theory that says for any system to be stable and last for any significant amount of time, it needs to have a dynamic balance between three very distinct fundamental components or functions.
And here are the three rules. First up, you need a force of concentration, some kind of inward pull that gathers material together. Next, you need a force of binding that actually holds that material together in stable structures like atoms. And finally, you need a force of expansion, an outward push that keeps the whole system from just collapsing in on itself. Get the ratio wrong, and the whole system just doesn't work.
So this framework comes from a researcher and author named Kevin L. Brown, and he gives us a totally new lens for looking at the structure of our universe. So let's do that. Let's see what happens when we apply this lens to the cosmos itself.
Now, this is where it gets really, really fascinating. What happens when we take this three-part idea of stability and lay it right on top of the fundamental forces that actually run our universe? And wow, the alignment is it's kind of remarkable. In this THD framework, gravity is the perfect candidate for the force of concentration. The strong and weak nuclear forces are what provide the binding, holding the nuclei of atoms together. And what provides the expansion? Electromagnetism and the overall expansion of the cosmos, pushing everything apart. The fundamental forces of our universe seem to map perfectly onto these three required roles for a stable system.
And all of that leads us right to the core hypothesis here. The numbers that define our physical laws, those fundamental constants, they aren't just random lottery numbers. They might be the specific values required to keep the universe in this three-way balance. In other words, they aren't a coincidence at all. They're a consequence of stability.
Now, look, in science, a good idea isn't just about what it seems to explain. It's about whether you can test it and, more importantly, whether you could potentially prove it wrong. That's called falsifiability, and it's what separates real science from just a nice story. So how could we actually test this idea?
So, how would this hypothesis get proven false? Well, a couple of ways. For example, if we ran computer simulations and found that you could get stable universes from all sorts of random combinations of force strengths. Or, what if we found definitive proof that the fundamental forces are totally independent and have no relationship to each other? Basically, if it turns out that stability is easy and common, not rare, then this idea is almost certainly wrong.
So, where does all this leave us? Well, it offers a pretty profound shift in how we look at everything. Instead of seeing our universe as the winning ticket in some unbelievable cosmic lottery, we can start to see it as maybe a natural, almost inevitable outcome of a fundamental principle of stability.
And that leaves us with this final, really powerful thought. The universe is not fine-tuned for life, it is stability-tuned for structure. And things like life, in all their amazing complexity, just happen to be a possible result of that deep underlying and necessary stability. The universe works because, in order for it to exist at all, it has to.